Okay, to the supply voltage. Okay, so the supply voltage, okay, is equivalent to, okay, we consider as V3 plus V1. Okay, the V total is equivalent to the summation of V3 plus V1. So your V3 here is 20 times I total plus with your V1. Okay, so your I total, okay, we found at 7.16 with minus 12.09 degree angle. Okay, so 20 times with 7.16, okay, with minus 12.09 degree angle will give you 143.2 with minus 12.09 degree angle. Okay, so this V3, okay, you plus with your V1, okay, which is 158 with minus 18.43 degree, will give you, okay, the V total is at 300.74 with minus 15.43 degree volt. Okay, so the phase angle between the supply voltage and the supply current, okay, we can find from this formula, which is the difference between theta V total minus with theta I total. Okay, so if you refer back, okay, so the V total just now give you, okay, the angle is minus 15.43 degree. So minus with your I total angle is minus 12.09 degree. Okay, so the difference between the voltage and the supply current, okay, is minus 3.34 degree. Okay, so the apparent power for each branch now, okay, we want to calculate the apparent power for each branch in phasor form. So we know that, okay, your I1, okay, from the calculated value, okay, is found at 5 with 0 degree angle ampere. Okay, so in order to find the apparent power, the formula used is Vs1 is V1 times with I1 conjugate. Okay, so you substitute the value for V1 with 158 with minus 18.43 degree times with your I conjugate of 1 is 5 with 0 degree. So your apparent power is 790 with minus 18.43 degree per VA. Okay, so for the second apparent power for S2, okay, the same formula is used. So V2 times with I2 conjugate, since, okay, the V2 is equivalent to V1. So your V2 is 158 with minus 18.43 degree angle times with your I2 conjugate, okay, which is 2.5 with plus 39.89 degree, because we know that your I2 originally is 2.5 with minus 36.83 degree, 86 degree. So the conjugate of I2 will be 2.5 with plus 36.86 degree. Okay, the multiplication of your V2 and I2 conjugate will give you the apparent power is equivalent to 395 with 18.43 degree VA. Okay, so for your third apparent power, okay, so the similar formula also used. Okay, so V3 times with your I3. So your I3 here is your I total conjugate. Okay, so your V3, okay, previously we know that V3 is equal to 20 times with your I total, which is 143.2 with minus 12.09 degree angle. So the S3 or the apparent power, okay, at V3, okay, is the multiplication of your V3 times with your I3 conjugate. Okay, so give you 1025.31 with 0 degree VA. So the total apparent power, okay, can be calculated or determined, okay, using, okay, two methods or two ways. Okay, the first one, okay, by the summation of S1 and S2 and also S3. Okay, so you sum all these three apparent power, we give you the total apparent power, okay, which is at 2153.16 with minus 3.32 degree VA. Or the second way or the second method, okay, is by using, okay, the VT times with your IT conjugate. Okay, so we know that your V total is 300.74 with minus 15.42 degree angles times with your IT conjugate. Okay, so previously we know that, okay, your IT originally is 7.16, okay, with minus 12.09 degree. So the conjugate of the IT will be 7.16 with plus 12.09 degree. Okay, so we multiply these both, okay, V and I total, okay, and then it will give you the total appearance power at 2153.3 with minus 3.330 degree angle VA. So in conjugate or in complex form, okay, so the answer for the total appearance power is 2149.67 minus J125. Okay, so from here, okay, we know that our total, okay, appearance power, okay, is 2153.3, okay, and from the total appearance power also, okay, in a complex form is the summation of the real power plus with your reactive power. Okay, so thus we directly can, okay, get the real power or the total active power is equivalent to 2149.67, okay, watts, and your reactive power is 135 bar. Okay, for the power factor of the circuits, okay, we found from the angle at your currents. So the angle at your total currents is 12.09. So which means, okay, the cos theta or cos 12.09 is 0.978. Okay, since it is in negative, so it's a lagging power factor. Okay, so finally, okay, to sketch the overall power triangles, okay, with the aid of appropriate diagram and labels, okay. So in x-axis is your P value, and your Q value is 125 because you get the minus, so it's actually in, okay, is opposite of this direction, okay, and your S is 2153.3. Your S is the summation of your P and Q, and the theta, okay, is 3.33 degree. Okay, so sorry, so you just, okay, make, okay, a correction here, okay, so because okay, I make, okay, a wrong, okay, our triangles, because your triangles must be at negative, okay, the Q must be in negative, okay, so you have an opposite direction of the Q, and also the angle there is 3.33 degrees, so please make a correction. Okay, so we just finished, okay, our question 7 and also our exercise 3. Okay, so I hope that you can understand, okay, the whole questions again, and also how to solve, okay, for all the kinds of questions. Okay, so with that, I thank you and good luck, and thank you for listening me. Okay. Assalamualaikum, salam sejahtera.